Hi, welcome everybody. My name is Jeff Mason. I'm going to give another minute before we start, just to allow the other audience members, if they're running late, to join the webcast. I'll be back in about 45 seconds. Okay, I think we're going to begin. I think we have critical mass. Welcome everybody, and thank you for taking the time out of your day to join this webcast. Today we will be doing a SAS 101, the most widely deployed storage interface. Today's event is hosted by the SCSI Trade Association. It's also referred to as STA, STA, and we'll be doing a series of webinars over the next few months as we launch our 24 gig ecosystem. Today's presentation will focus on SAS basics, what SAS is, how it evolved, the ecosystem, and its benefits. My name is Jeff Mason. I'm a proud member of the Board of Directors of the SCSI Trade Association. My day job is a principal R&D engineer for TE Connectivity. My partner in today's presentation is Jeremiah Tussey.
Hello, everyone. I'm Jeremiah Tussey, the Vice President of the SCSI Trade Association. I come from Microchip Technology as the Alliance Manager of Product Marketing in our Data Center Solutions business unit. I'm excited to be here today with everybody.
Thank you, Jeremiah. Let's get to the next slide. Just to identify what STA is, it was an organization that was formed 20 years ago. It's an industry alliance for all the key partners associated with the ecosystem of SAS. It is basically an organization that markets and promotes all things SCSI and SAS. It's actually the marketing arm of the institution, and it is the subcategory known as T10. The members that you see on the right are some of the key companies involved in the alliance. We'd love to have more members join. If there's an interest, please reach out to us and we will administrate you accordingly. Another industry partner that we are closely aligned with is SNIA. The SNIA is a storage networking industry alliance, a very large organization with 160 unique members, 3,500 active contributing members, and which dovetails to over 50,000 IT users and storage professionals. So what is serial attached SCSI? Basically, SCSI is a small computer systems interface standard, and this was generated by the American National Standards Institute, and it basically defines the physical connections between the host and the peripheral devices that they target. The standards define the commands, the protocols, the electricals, the optical interfaces, the connectors, the cable assemblies, and it targets hard disk drives, solid-state drives, tape drives, CD-ROMs, scanners. SAS is a faster, more flexible interface than the previous parallel data transfer interface. The command set is really robust. It's been used across the industry, and it's primarily targeting enterprise workstations, servers, and storage applications. It's been proven for over 2 decades. The command set's been implemented in other storage interfaces, including Fiber Channel, USB, IEEE 1394, and InfiniBand. And the timeline here shows the conception of SCSI in 1986, where the technology was strictly parallel. And with each generation that came after that, we had a doubling of speeds. And STA was actually created in 1996 to promote and market the technology across the whole ecosystem. Parallel technology continued to the early 2000s, where as the speeds got really fast and the cable assembly distances got longer, it was really hard to stay with parallel. And the SAS technology was born. In 2004, it launched its first 3 gigabit per second technology and has been doubling ever since then, until we're at 24 gigs per second now, and launching our first PugFest in this month. So when we went from parallel to serial, there was, the challenge that was, I said earlier about the cable lengths and the data rates. It was impractical to go over parallel buses. So the serial technology was born. But there were more advantages than that. SAS supports a 64K device, where SCSI in parallel was only 16. It eliminated the clock skew issues and the bus contention issues. It also supports SATA and the serial ATA. This allows the storage designer to use both in configuration. The infrastructure that enterprise storage was built upon surrounded SAS, and SAS and SATA are the interfaces for rotating media today, and the best defined interface for total cost of ownership. And it remains the backbone of a cost-effective, large-scale cold or cooler systems for rotating media. The expanders allow for fan-out of really large numbers of devices, whether they're SAS or SATA, and SAS continues to innovate. We continue to try to improve the performance and the reliability, launching with our 24 gig ecosystem now. The capacities will improve, and so will the optimizations. There's a large, SAS spans the storage spectrums, and you can see the 4 that are listed there. You can either direct attach the storage, you can do the SAS fabric and external storage, and the drive technologies are common with both hard drives and solid state. You also have to realize that this is a technology that's been proven and reliable. All the ecosystem partners, whether it be HBAs, or connectors, or cable assemblies, expanders, and switches, have all been out there and proven over and over again to provide reliable performance. When it comes to the connectivity and the assemblies, we have 3 primary technologies: passive copper, active copper, optical connections for 100 and beyond. And beyond that, we even have numerous connector formats and features such as mini-SAS and mini-SAS HD, QSFP. So it really provides designers and storage systems to configure orientations to their components that can be optimized for their particular needs. And another unique aspect that's worth mentioning is that the SAS connectivity supports SATA. So if you had a storage system that wanted to combine SAS or SATA, it's really unique that with that, the same connector interfaces will allow you to do that. And that gives you backwards compatibility to the prior generation. So your infrastructure is maintained as you move forward with the technology.
Hi, I'm going to go and speak a little towards the applications of SAS and how it is used in a lot of the enterprise deployments today. I wanted to remind everyone that you can ask questions by typing in the box below the presentation on the screen at any time, and we will tackle as many of them as we can in our allotted time. If we don't get to your question, we will certainly answer it via email a little bit later after the call here. And also I wanted to point out, if you guys wouldn't mind, please, at the end, if you could rate this webinar as we conclude. So getting into the SAS server applications, first off, I'd like to touch base on these server level ones. So there are a number of applications that can be serviced by SAS, as well as SATA attached to SAS infrastructure. One of the primary implementations is a high bandwidth caching HBA application, as shown here. And this is basically a single server with just a RAID controller, using a RAID 0 configuration typically, to a bunch of SAS or SATA SSDs installed to form a high-performance cache. This targets dependable performance with SAS or more economical performance using SATA. And it's also a type of configuration that's effective in web access server applications, as one example here. So moving on to another SAS server application is the dense cloud storage. So this dense cloud storage is similar to the previous server implementation, but you expand out to embedded SAS expanders on an internal backplane. You have a lot more drives interconnected as raw storage capacity for the most effective bulk storage access. And this gives you more of an all-in-one tiering solution in a single box, allowing dense cloud accessible storage, servicing a more economic capacity solution within a single server. Moving on to external storage applications. So SAS allows external connectivity through a number of connectivity options that were just shown previously. Here we have a SAS server similar to the server shown just a couple slides ago, attached to an external JBOD, which is just a bunch of drives. This could be implemented in a hybrid array JBOD fashion or as an all-flash array if you have all SSDs installed in the JBOD. This allows a single 24 gig SAS RAID controller, providing remote expansion to 24 gig SAS SSDs, or 12 gigabit per second SAS, or 6 gigabit per second SAS, or even 6 gigabit per second SATA hard drives and SSDs as targets via a 24 gig SAS expander designed in an external enclosure. So overall, this drives a value proposition of more dependable flexibility, as well as an element of performance depending on the number of SSDs you include in the enclosure. Another external storage application is similar to the previous one, where you have multiple servers that are attached to multiple domains to a cascade of JBODs. And here, this allows you to have redundant scalability and flexibility in the same application that was shown previously. You have your primary connectivity from a server A, here on the top left area, going through the topology attaching to an expander A within the JBOD that connects to the primary port of SAS drives or a SATA drive that has a paddle card installed in front of it. The other port is serviced by server B that goes through the same infrastructure but connected to a separate I/O card in the JBOD. That's a separate card. Usually these types of JBODs have multiple cards to service the different domains to provide the redundancy. Overall, the dual 24 gig SAS RAID controllers provide multipath remote expansion to 24 gig SAS SSDs, or 12 gigabit per second, 6 gigabit per second SAS, or 6 gigabits per second SATA hard drives and SSDs as targets via an external 24 gig SAS expander in the enclosures, just like the previous application. So using the previous examples as parts of a scaled out system configuration, you can now see how it all comes together to scale into a broader storage ecosystem. This is the scalable storage ecosystem. Within that ecosystem, you typically have interconnected host attached SANs, or storage area networks, or NAS, network attached storage appliances, which once again are serviced by SAS infrastructure. As you zoom in to the lower left portion of the slide here, the servers would then be interconnected through a SAS switch as one example, or directly to JBODs in a cascaded configuration. And you can see some examples of cascades on the right side of the slide. Various JBODs and storage enclosures are typically attached to the overall ecosystem depending on the needs of the storage medium. And those mediums could be serviced by all-flash arrays with nothing but SAS SSDs for your highest level performance and caching tier and servicing the hot level of data in the ecosystem. Or you have a more warm tier serviced by hybrid arrays with SAS SATA SSDs with SAS SATA hard drives combined together in a single enclosure. And lastly, you'll have the colder tier storage arrays, which are serviced by typically SATA hard drives and typically using one of the latest technologies, SMR, providing the lowest cost tier to the storage ecosystem today. Within each of those storage systems, you have the interconnectivity that is supported natively by SAS-defined connectors that can support SAS and SATA simultaneously. And then it all comes together where you have multiple domains that allow you to access through dual SAS expanders embedded in those JBODs, and then connect to the SAS or SATA devices on the back end via the redundant ports, just like shown on the previous slide. Okay, so here we have some common data center applications. It is just a sampling, and there are other applications environments that can certainly fit on this slide. But basically what we're showing across the x-axis is a representation of the relative performance requirements that can be in the form of IOPS, which are IOs per second, or as throughput. The y-axis shows whether the application is oriented for reads or writes, and depending on how much is more read-intensive and how much is more write-intensive. And then the size of the application bubbles is meant to represent the general range across these different spectrums, these different axes. And then the larger the bubble, the greater the range for reads and writes that is represented, as well as the performance demands. So where does SAS technology fit in the data center? Well, pretty much everywhere. So as is shown here with the whole box highlighting the section, the big reason for this is that SAS technology supports the operation of SAS SSDs and hard drives, as well as SATA SSDs and hard drives. So SAS isn't just for high performance applications. It fits all levels of applications and use cases in these different areas. It supports small and large topologies that could include a mix of SAS and SATA drives. So finely tuned storage can be built for pretty much any application, from cloud to high frequency transactional. SAS is also a great solution for both server storage and external storage, and has been for many years to this point. And whether it is implemented in a direct attached storage server or in a hyper-converged cloud architecture, or fault-tolerant or redundant operation, it's bulletproof in a number of storage racks that the SAS technology can cover across the spectrum. So how well does the latest generation of SAS, 24G SAS, 24 gig SAS, fit into the data center? From an overall technology capability perspective, 24 gig SAS is backwards compatible, so the same topologies with SATA as well as SSD and HDD mixed environments still work quite well. So let's look at the performance aspect of 24 gig SAS and where it's a good fit. So of course, we're turning the speed knob to improve performance over 12 gigabit per second SAS, so applications on the right side of the chart will see the most benefit. Since many of these applications want the fastest reads and writes, applications that have bigger emphasis on writes will benefit from the performance gains that come from 24 gig SAS. You may ask the question, if 12 gigabit per second SAS works for these applications, why do we need even higher performance that comes with 24 gig SAS? Well, I think it's safe to say that faster transactions, faster downloading, more seamless streaming, and better gameplay are always going to be in demand. So continued development in faster storage and networking will continue for the foreseeable future. Whether it's SAS or other technologies, SAS is a quite versatile technology to span across the spectrum, especially with the latest 24 gig SAS. So with 24 gig SAS, we will help these applications perform even better, which is why the T10 Technical Committee does what it does to improve the technology. So here is a list of the companies who are involved in standardizing the SCSI storage interfaces and developing the SAS specifications. As you can see, there are numerous organizations involved in the development of the new standards and enhancements of existing standards. So without this industry-wide support, SAS wouldn't be where it is today as the model enterprise storage solution. As an overview of why SAS has been such an important and highly used technology in the data center for decades, it is seen as the most trusted, dependable, and reliable storage technology for the data center with security capabilities, trusted platform capabilities, and just data center ready levels of built into the standard and the products that are built around SAS. Its flexibility is unmatched by any other storage technology with its support of SAS, SATA, SSDs, and hard drives, as well as being backward compatible with previous generations. And not to mention, there's other technologies that come into play here from a medium step point. You have CDs and tapes that they'll attach to SAS infrastructure as well. So complete flexibility across the wide spectrum. It's also still the most scalable storage technology, able to support architectures with thousands of devices, as well as the highest capacity devices on the market. SSDs, for example, are available up to 30 terabytes with larger capacities on the horizon. And that's not to mention the low-cost metrics of SATA and SAS hard drives using SMR and other advanced technologies that are starting to come to light. And well, so with the economics, the high performance and the gigabytes per dollar, as well as a large and mature ecosystem of suppliers and developers, all bring it all together to give you the most optimal price performance, price per gigabyte. It's really well suited in the middle spectrum of economics, as well as being able to branch out to the different spans of the spectrum for capacity and performance. So overall, SAS has a long history of innovation and isn't going to stop anytime soon. Innovations are still coming, and we are continuing to build upon the enhancements and feature sets that support these different levels of the pillars that build up SAS today.
When you give it a comparison of the typical deployment, you have three options, and you look at all the attributes that we have outlined on the left. SAS continues to rise to the top in the form of scalability, flexibility, the consistent, reliable performance that it provides, and also the hot swappability that you get with managing it. Overall, it continues to hold a very large share of the market. Even when you compare the speeds of SAS Gen 3 at 12 gigabits, it's about 20% faster when comparing it to PCIe Gen 3. But we realize that NVMe usually is, deployed in a by 4, but that comes at a cost of, additional routing, backlink complexity, and real estate.
Thanks, Jeff, for that little side note. Yeah. So here we're going to touch a little bit more on the 24 gig SAS highlights. Some of the things I was mentioning earlier. This gets a little bit more into the details to let you know what's coming. So here we have enhancements that were made into 24 gig SAS, also known as SAS 4 from a standards perspective. And some of you are probably familiar with SAS, which has been deployed for many years now and is the drive of choice for storage or server applications. For the requirement of the highest reliability and 24/7 operation. It provides the most comprehensive management capabilities and provides performance sufficient for most data center applications. And to be clear, at Microchip, like other storage companies, we understand there are benefits to using NVMe or SAS type devices in various applications, and there is certainly some overlap. Here we'll concentrate on 24 gig SAS, and where it provides the biggest enhancements across the physical layer as well as the protocol and block level layer. Excuse me. So one of the areas that we've improved is doubling the bandwidth. The single lane bandwidth has been effectively doubled to a 2.4 gigabyte per second bandwidth capability, and this was achieved through the implementation of enhanced 20-bit forward error correction with a different gigabaud rate. So working together, they provide higher throughput and IOPS performance, as well as a more robust data and reliable connection between the ports within the ecosystem. We've also enhanced the training algorithm. So a SAS4 transmitter has a training algorithm built into it that will continuously optimize the signal tuning. And this is to take care of different cases across the spectrum where you have temperature variations, voltage variations, things that affect the system on a day-by-day basis. This allows it to adapt for different effects that could affect the signal integrity. So we'll have an optimal signal at all times. So diving down more into the protocol and block level enhancements, so some of these enhancements are targeted towards the operational and functional implementation of the flow of data through the ecosystem. There's been fairness enhancements to provide performance consistency across the large and mixed protocol topologies. As I mentioned earlier, we have a mixture of SAS and SATA, different data rates, different types of devices. You can have a lot of different effects with these various devices all in one enclosure. So you have some improvements on the fairness aspect to give access where it's due. And then on the more high-speed SSD level of interconnectivity, we have storage intelligence and persistent connections that have been added into the standards over the years. And this will improve the SSD efficiency, improving latency and quality of service that allows for these latest SSDs that are coming to market. And then last but not least, we have SMP priorities. So SMP is a management protocol within the ecosystem. So this allows you to have effective management of the configuration of different metrics that are being reported up and down the system from the end of devices, or different levels of error conditions. There's a lot of management information that may be running in the background throughout the topology. So there's been priorities given to those type of management communications so that you're make sure everything is in sync at all times. So you may have seen this roadmap before, and we'll certainly see it again. This is a high-level roadmap for the technology, mainly focusing on when the technology begins testing, when you can expect to see the first products come to market, and finally when the next generation of SAS will come along. The leading edge of the technology bars represent the first approximate plugfest dates. And with the plugfests, it's kind of the first time that various companies get together to test various ecosystem components and confirm interoperability, verify that different portions of the standard have been implemented correctly and properly interpreted by the different companies. So you come together and make sure everybody's products talk together as they're expected. Typically, there are multiple plugfests for a SAS generation with products of differing maturity along the way that get tested. So, for example, over the course of 12 to 18 months, you'll see the first products begin to hit the market. This is represented SAS generation. And during that time frame, you'll have multiple plugfests as different products come to market from different companies, and you have different enhancements, later versions of the models. So you get a chance to bring all those in and interconnect them with all the ecosystem vendors to make sure everything operates properly. This is common for previous generation technologies that continue to be used while newer technology is being deployed and adopted. So lastly here, we show the 48 gig SAS on the roadmap. So we are expecting a follow-on specification to come to market. This may shift based on market dependencies. So please watch this space in the future. And then in addition to improvements to performance, reliability, and quality of service, we are looking at other ways to innovate and offer more SAS options. So stay tuned for more on this as well. So in summary, I'd like to reiterate, SAS being the most widely deployed storage interface as it spans the entire storage spectrum from direct attached storage to external storage implementations to end devices. Because of its flexibility, proven reliability, and proven attributes, finely tuned storage systems can be designed and built with SAS for pretty much any application, from cloud and social media to high-frequency transactional and financial applications. New innovations to further improve data reliability and performance will position 24 gig SAS to better suit those data center applications as well. So this concludes today's presentation. Let's see what questions have come in from the audience. And I would like to point out today's webinar can be found in the attachments and links section on the screen. So please reference that as you see fit. And we'll go ahead and open it up to some questions here. So one of the first questions we have received is, you mentioned that SAS supports up to 64K devices. Has anyone been able to test a SAS topology of that scale? So although the technology is capable of supporting 64,000 devices, the realistic implementations based on routing table designs into expanders and controllers of today, you see 1,000, 2,000 drives per, or attached devices per topology, but you'll have a lot of these topologies in parallel. So the amount of devices you support can certainly span out to that level of devices, but in practical reality with the I/O flow and RAID and different applications and factors, the average size today is probably no more than 2,000. Okay, so one of the next questions we have is, what are the key gaps in NVMe technology that are in place for SAS? Jeff, you want to cover a couple of the topics from the NVMe versus SAS comparison?
Sure. I think we all acknowledge that NVMe, from a performance and a latency standpoint, is at the top of its class. The fact remains that as we develop and extend our innovations in SAS, we are in the rotating media side. So scalability and that flexibility and add-on to configurations is where we're going to do the best. The SATA side is generally going to be lower in cost, perhaps not quite at the capacity and reliability of SAS, but overall I think the evidence proves that it's the one that's going to be implemented in enterprise and not in the PC world and some of the other higher volume, lower cost markets.
All right, thank you. And there was another question here about the difference on device level SAS SSDs versus NVMe SSDs, which is pretty much answered by the same level of information that compares NVMe versus SAS. So overall, if you look at it on a lane by lane perspective, SAS is a faster interface, but in today's typical applications, NVMe drives are deployed as a by 4 interface in most applications, maybe even by 2. So they have some advantages there natively. But you do have some capabilities built into SAS drives that has been hardened over many years, that with hot plug, surprise hot plug, different ways to support those environments that you need to swap drives as needed. Those things are natively built into SAS, and those are things that are still they're definitely being built up on NVMe drives, and they are making a lot of progress there. So that's just one of those things that's really required in enterprise applications today. So eventually NVMe will be there 100%, and they're working their way to that today. One of the other questions now we have is, what's the maximum length of external SAS 24 gig copper cables?
Yeah, I would say in general we're going to follow the same lengths that we had in the past generations at 1.5 meters to perhaps meters. After that, you might be looking at an active technology, but overall those are the safe numbers.
Okay. Well, got a lot of questions all of a sudden popping in here. Okay, so one of the other questions we have, what's the real-world bandwidth in megabytes per second of by 4 24 gig SAS external port? Do SAS 24G switches actually exist? And if yes, how many by 4 ports do these have? So overall, the real-world real-world bandwidth of by 4 24 gig SAS external port is 9.6 gigabytes per second. So that's a full bandwidth rate, and that's supporting 24 gig SAS by 4. There's new cables now that are doing by 8, so even doubling that as well. Asking the question about 24 gig SAS switches, that's a implementation of specific customers. I can't talk to what different customers may be doing, different vendors. There were some SAS switches that did come to production in the 12 gigabit per second range product line. So I would expect we would probably see similar products coming in 24 gig SAS. So how those are implemented as far as port counts and port widths, I would assume by 4 is by a default width for certain connectors, but there are new connectors in the SAS specification that support by 8 in a similar form factor now. So I would expect that you would see some of those switches to be able to support those wider connectivity. Okay, moving on to a couple more questions here. Is STA working on or with tri-mode U.3 SATA, SAS, and NVMe? I could take that answer. So the way we are defining our standards, we are focused on SAS technology. The U.3 specification is something that has been standardized through the SFF organization. That's a sub-organization to SNIA. So we don't directly drive the requirements for that, but we are certainly open to supporting these type of applications that allow different types of connectivity that include SAS products. So and there's probably not much more that I could say, but we're not actively working on those specifications, but we are definitely supportive from a standardization standpoint. Okay, it looks like we have one more question here, and then we can perhaps wrap it up unless there's any more questions. In one of your topology diagrams, you showed a mix of SAS hard drives, SAS SSDs, and SATA hard drives. Could you discuss again why some would mix drive types like that? So certainly it's really a choice of the implementers here, but some of the ideas behind doing the different types of media is, I'd kind of touch base on this, is you in a lot of these applications, you have different tiers that provide different metrics for hot data versus warm data versus cold data. So when you need higher performance, lower latency, that's typically where you would use SSDs. And depending on your performance level or your cost level, you can use SAS SSDs for the highest performance at an added cost, or you can use SATA SSDs that give you a slightly lower performance metric, but at a much better cost. So what you typically see is a overlap in some of the different areas in the overall tiering, where you'll have SAS SSDs towards the top of the line, a mixture of SATA SSDs with SAS SATA hard drives in a cached type of JBOD that provides more of a medium-level warm access data platform. And then down the spectrum, you would have your colder data, where you would have SATA hard drives, SAS hard drives, all the way down to SATA hard drives with SMR that provide serialization and striping of data based on SMR technology that gives you the lowest cost per gigabyte. And then there's even tiers lower than that include tape and CD technologies as well. I don't show that here today, but that's certainly part of the ecosystem that can be supported with SAS infrastructure. Okay, so there was a question about what is SMR. So SMR is shingled magnetic recording. So there are a number of previous presentations that STA has touched a little bit on what SMR is. There's definitely a lot of public information out there too. This is a technology that a lot of the main hard drive manufacturers are deploying today in various applications, specifically cloud, data center type of applications, where you need the lowest the lowest cost per data metric. And what it allows is the striping of data on the disk platters themselves actually overlaps to a degree, so you get more compact amounts of data being formed on the platters. So it's got a specific use case, and it requires more of a serialization of the data streams to and from the drives, so more management from the host. So a little bit more oversight. There's a little bit more controls of how the data is being put onto the drives. It's not as suited for more random IOPS, but it certainly gives a better compact method of recording the data. Okay, it seems to be all the questions we have for today. We'd like to thank you all for attending our presentation, our Bright Talk webinar today. We hope you got a lot of value out of this. And please reference the attachments and links and leave some feedback for this presentation. Thank you very much.
Thank you, everyone.